Hey guys, so this is another one of Leaf Tree's educational learning videos, and today we'll talk about the properties of real numbers. So before we get into the hard stuff, we're gonna review the basic properties. So first comes the reflexive property. That states that basically states um, that just states that like if any real number equals itself, it can be the opposite way around. Next one, we have the symmetric property, and in the symmetric property, we pretty much have the same thing. So if x if 1 equals x, then you can rewrite it as x equals 1. Next one we have is the transitive property, and that one says that if one real number equals another one, so if a equals b and b equals c, well, we know that a equals b, so we can substitute b for a. So when you substitute a for b, what you get is a equals c. So that's the transitive property. Now let's move on to the addition property, which basically states that if one number, so if any real number like a is equal to another real number like b, then when you add the same amounts to each side, they would still equal the same. They would still equal the same. So maybe a plus d is equal to b plus d. Now let's move on to the multiplication property. Multiplication property is the same thing, except it doesn't deal with addition. Instead, it deals with multiplication. So we're gonna replace the addition sign with multiplication, and this addition sign with another multiplication. So okay, so our next, so let's get into the kind of difficult stuff, but we can handle it. So let's get into that stuff. So the first one, so the first types of when you learn the properties of one type of operation like addition, subtraction, multiplication, then you can obviously transfer to the next without any problem, because the properties are all the same. There's nothing different about them. It's just that all the properties of each operation are the same. Just that they differ in the type of operation. So maybe in the properties of division, instead of a multiplication sign, we would have a division sign. So let me use a pencil marking here, and we have a division sign here. Now let's move on to the properties of addition. So the first property of addition we're going to talk about, and of course the exact same properties is also in subtraction, multiplication. So in the closure property says that one real number plus another real number results in another unique real number. So perhaps a plus b, that wouldn't result in a. It wouldn't result in b either. It would result in something that is greater than a plus b. So it would result in a unique real number. And we denote a real number using this type of R symbol. So the next property we have is the most common you heard of, perhaps, and if you didn't, we're gonna write down strings. Well, the next one is called a commutative property, and let me write it down. Commun commutative property. And the commutative property, it states that when that the order of the operations can change. So a plus b can be in fact switched around to b plus a. It would result in the same real number. So perhaps 5 plus 2 would equal the same sum if it was 2 plus 5, right? Because 7 plus 7 equals 7. So our next property we have in the addition section, wait, let me get my text out, is the associative property. And the associative property is just like a little more complicated version of the commutative. So in the associative property, what we have is basically 3 numbers instead of 2. And what I didn't say was that in a commutative property, you can only have 2 numbers that can be switched around. Not 3, not 4, but only 2. In the associative property, we have the same thing, except it deals with just more numbers. So perhaps we have a plus b plus c, and it also tells you what numbers to do first. So perhaps it'll tell you to do b plus c first, because parentheses mean parentheses in front of 2 numbers mean that you have to do those two. You have to operate on those 2 numbers first. So perhaps this would mean we have to do a plus b first. This would mean we have to do b plus c first. So we're depending on where the parentheses is, you have to change what numbers you have to add first. But that does not actually change what the sum is. So let's say you had to do b plus c first, which was what we first said. Let me in fact denote that with a sign. Let me see. Wait 1 second. Back to the future, not back to the future. So I'm gonna denote the parentheses with the blue color, so we can see what numbers to do first. So here we can do b plus c first, and here we can do b plus a first. Do we get the same answer on both sides? Yes, because all the numbers are staying the same. Nothing is changing. What you're actually doing is just changing what numbers to add first. So this is like saying, if there are 3 people on a line, then if you be unfair and take the 3rd person and let him go into the theater first, and the 2nd person into the theater next, and then the 3rd person into the theater last, you still would have got it, all of the movie watchers inside the theaters. You wouldn't have one left outside. If you took the first one, if you took the 2nd person and put him inside the movie theater first, and put the 1st person into the theater last, and the 3rd person into the theater secondly, then you would still have the same. You would still get everyone inside the movie theater. There will be no people left outside, standing in the rain, hanging outside like old people. So this is probably okay. Yes. So we have 2 more properties left, and from there I'm going to explain why all the properties do not change when you go to the next operation. So the next thing we have to hang on about is the identity property. And I don't think it deserves to be capital. I didn't put any of them capital. Property. And what I actually forgot to do is add a decimal point. So yes, you actually have to be specific and name what operation you're doing. Otherwise, I mean, if you're on a test, you do that because you know in your own mind what you're doing. So identity property, that just burst my secret out. So the identity property is pretty straightforward. What we have is a number, a real number plus 0 is that same real number. So like a plus 0 equals a. So like 1 plus 0 is 1, 2 plus 0 is 2. So something plus 0 equals something, that same something. So that's the identity property. We also call it the additive property, so perhaps I should add that, additive property. Now let us move on into the property of opposites. And no, that doesn't mean bedtime is morning time. Morning time is bedtime, which is pretty much be fun because we didn't have to go to school. But this is something else. This is actually the property of opposites in real numbers. And before I go hanging on to that subject, what we have to do is highlight this in a different color so you won't go sleepy, I think. So the property of opposites, and while I'm highlighting it, I'm just gonna go hanging on. It's when you add the opposite operation of a number to itself. So perhaps what is the opposite of 2? Or should I say positive 2? The opposite of positive 2 is negative 2. So what you would do is okay, forget it. What you would do is 2 plus minus 2, and that actually equals 0. When you do one number, add it to the exact opposite operation of that number, in this case the negative, then you always get 0. Always. So let's say 3 plus minus 3, that would equal 0. 59 plus minus 59, that would equal 0. So that is actually a oh yeah, I didn't write that down. I apologize. Property of opposites. I'm sorry, I didn't want to be unfair. Property of opposites. And you probably see why they say property of opposites. It's because you're doing the opposite of operation of what the original number is. So this one has a positive so this is plus 2 and then minus 2 equals 0. Plus 3 minus 3 equals 0. And also so it can be like, let me see if I can actually illustrate this. So this is just like art. Black plus the exact opposite of black is white. So black plus white equals something in the middle. So mixing in colors, or maybe red plus purple, magenta, sorry, I didn't go to first grade, so I don't know my colors, equals something in between. It's actually not mixing in correctly. So not my fault there. The makers of Outrageous fault. So what you need to know is, oh, and by the way, there's only one more thing I need to go over with you: the distributive property, and the next one is the property of reciprocals. So when you go to other operations, so instead of addition, maybe it's instead of addition, maybe it's subtraction or multiplication. You would still apply the same laws, the same properties. The only thing you would change is the operation. So this would actually be multiplication. This would be multiplication. So that's what you need to know. So there's only one rule in the multiplication that I thought I need to go over, and that is the property of reciprocals. And you know what? I'm gonna save this. I can't bear to erase this. I just can't bear. I don't know why I'm naming it that. That's that. Hello, canvas. Okay. So our last step will be the property of reciprocals. Property of reciprocals. So in the property of reciprocals, it's pretty much the same thing as the property of opposites. So all you do is find the reciprocal of a number and multiply it. So in this case, what we would have is a real number times the reciprocal of that real number equals 1. So maybe 5 times 1 over 5 equals 1. So that is the property of reciprocals, pretty straightforward. And lastly, we'll go over the distributive property. And yes, that's pretty much what you thought as, distributing candy. But too bad it's not that sweet, so sour. So this is the distributive property, what we're talking about. So in the distributive property, what we have is a number, a real number, times this block of expression. So what you do is distribute that real number along with these two real numbers. So a times a times a I apologize. A times a, and you're gonna add this. You're gonna put this operation into here. So let's say plus a times b. A times b. And so that is the distributive property. So that's the end of our video, and thanks for watching.